Few more minutes. All right, then I guess we're starting. Hello, hello, morning, everyone, or afternoon, wherever you are. This session is about Cloud Security 101. We are joined with Kriti from Checkpoint. Hey. So we will start with a little welcome note to you from Dennis. And then we will go through some housekeeping, and then we will start the session. And this session has two parts, a presentation and a lab, where you will be doing hands-on exercises. Over to you, Dennis.
Thank you, and welcome to everybody. This is day 2 of our 2-week training sessions, all leading up to the summit that happens on the 15th of June. I want to give everybody a big welcome. And kind of say that, you know, what we really want you to experience and to feel on this training is we want you to learn a lot. We have this sort of 10-day high energy experience. It's all about this collaboration between developers, security professionals, executives, this whole intersection of practitioners. And we really try to find these sessions that are not kind of very led by individual experiences. You know, it's all about real world concepts and real world actions. And I would also say that, you can still add new sessions. Historically, some of the best summit sessions were actually created during the summit. So keep an eye actually on the schedule, because it's going to change, not in terms of modifying a lot of things that's already there, but adding a lot of new sessions. And if you have good ideas, or if you figure out that you really think that, hey, we could be covering something else, hey, let's do something about it. We expect you to participate. We expect that you care deeply about this topic. We really want everybody to sort of have mutual respect, have some kind of objective distance on your comments. Remember that, this is multicultural, multi-geography, multi-experience. Nobody's 100% right. Everybody, has the value of their opinion. And we want you to challenge, right? The idea here is to be able to collaborate and be able to learn as we do it, and be solution focused, right? So again, let's focus on real world kind of comments and experiences. Openness is really important at the summit, so everything we do is open. As you see that we're recording this video, it's all available on YouTube. We're publishing it, we're trying to share as much as we can. The summit is a great opportunity to share a lot of things that sometimes professionally we can't share, and it's sometimes very frustrating that we keep reinventing the wheel. So the summit provides an opportunity to share a lot of the materials, share a lot of our ideas, and then we try to capture, and there's a whole team that we also have that is trying to facilitate the creation of all these materials. And it's very important that everything that we do here is released under Creative Commons or an open source license. And if you don't want to be identified, just don't turn on your video and use NA as your name during the session, right? But the point here is everything we do here, at least on this session, is on the record. We publish everything, which actually makes everything smooth and easy, but also creates a lot of great materials for the future. Respect is super important for us. We're here to collaborate. We are, again, a wide community, so nobody should be discriminated or harassed based on their race, gender, age, religious appearance, and experience, or anything else. We do take this very seriously. If you, feel any kind of abuse behavior or something happens on this, let us know. The team is around, and we, everybody expects us to put a certain level of professional and respect on the summit. And we do have very low tolerance for this, because we are a wide and diverse community, and respect is super important for everything we do. So finally, share your views, tweet about this, invite, join our Slack channel, learn a lot, and invite your colleagues. And by the way, if you not notice, I've made it briefly this morning. Basically, we kind of ask for people to buy a ticket, but if you don't, just choose one of the free options. What we want is to have as much talent as possible here at the summit. And with that, over to you. Actually, sorry, I wanted to find a little housekeeping things.
No problem. So we will be using all the functionalities of Zoom. Please feel free to give your reactions with the reaction buttons, ask your questions in chat. Because we are a small group, you can, if you have burning questions, you can unmute yourself and ask them to Kriti as and when they arise as well. The documentation, as Dennis has explained, will be shared on the website, and everything is recorded, so it's all going to be public. So you don't have to take too many notes during the session. Just focus on the session and try to get as much as you can. And we're ready for you, Kriti.
Thank you, Didar. I'll start with sharing my screen first. Is everyone seeing my screen?
Yep.
Yep, perfect. And can you all hear me correctly? I think that's clear. Right, thank you. So hello everyone, and thank you for joining us today. I am going to run through a Cloud Security 101. And thanks to Dara and Dennis for organizing and having me on this. A short introduction about myself. My name is Kriti Mohun. I work as a security engineer for Check Point Software Technologies for the last 6.5 years. Before this, I was with Qualys, working on the vulnerability management side of things and web application scans. And then I started my career being a Cisco firewall administrator. So the introduction today is effectively for cloud security, and just run through some very fundamentals of cloud security and what is it that you need to have as a person when you start embarking your journey into cloud security, understanding what lives in the cloud, the different types of cloud deployments, the different types of cloud services. And again, this is going to be very, very high level, guys. But if you do have any questions in between, please feel free. I will try and attempt to answer all the questions you've got. We will also look at cloud attacks examples. So what is it that you should be wary about in today's sort of trending time? And overall cloud security posture, try and safeguarding your assets in the cloud. And we will finally be doing a hands-on lab on Checkpoint Dome 9, which is a security tool which provides you with cloud visibility, IAM safety, and regulatory compliance. At the end of the session, I do hope I will help you adapt to and also adopt the cloud security mindset. Really look into real world problems as people are facing today, understand a little bit around the challenges with cloud security today, understand what's your position in cloud security, and then again try use Dome 9 as a security tool to understand your cloud security posture. So I do believe very strongly that very, very often when we start looking into security, we just jump into the tech side to try and solve a specific problem. So what I felt like in the beginning was, fine, something is not working. Let's look at the logs. Let's look at access control list. Yes, it will solve that issue at that point. However, as a security administrator, someone who is looking at overall security, it is a fundamental question to ask when embarking into the cloud is how many points of entry or backdoors are being opened with specific services being deployed in the cloud. So this, I believe, is a key question for anyone working in the security industry. And this kind of leads you to get a guideline of what is it you need to do next. Now, what you need to do next is also underlying an understanding of the nature and the characteristics of the cloud. So what is the cloud about? The cloud is a set of infrastructure which is made available for users either publicly or privately. Main characteristics of the cloud, and one of the reasons why cloud is so popular today, is because it's agile, it's elastic, it's scalable, it's cheap, super cheap. It's got resilience. You could have a service set up, and next thing you could have a DR capability set up, and the ease of deployment of all of these different pieces makes the cloud a very, very attractive option for businesses today to provide services to their end users. Now, with the cloud having such great characteristics and more adoption means that your data, customers' data, are being hosted in the cloud, more and more of them, more and more assets are being deployed into the cloud, okay? So what's in it is effectively protection of your data is key, protection of your assets is key. And why is that? Is because infrastructure in the cloud is shared. We very often see at the moment there is a trend of using multi-cloud platforms. There are different services which are being deployed into the cloud and in different environments. There is a freedom to log onto the cloud and deploy any specific services. There are multiple people going into the cloud to do particular IoT hosting or any web application deployment. So all of that is happening in the cloud at the same time. I can imagine, I mean, if you imagine in your head, it just sounds like chaos. Suddenly, it's like this thing's gone out of control and there is a lot of stuff out there and sometimes you don't really know where to start. So the baseline to try and understand what to do in the cloud is to understand where your responsibility lies. So in the past, there used to be a myth that everything in the cloud is the cloud, belongs to the cloud, and I have absolutely no sort of responsibility for any level of security. But that, I'm glad, has gone, and that is the past. So people now understand that your data is being hosted in the cloud. Your applications are being hosted in the cloud, so that's the business, belonging to the business. The operating system in the cloud is also up to the business. The network configuration in the cloud is up to the business. The encryption is up to the business. What is not up to the business is the compute side, the storage, the database, the networking, and the general global infrastructure. So this is the split of the responsibilities. And that's what makes the cloud, attractive as it is, but also understanding the baseline of understanding where you start and what is it you need to protect in the cloud could potentially make things easier to you. So that leads us to sort of go to the next stage, which is understanding the different cloud deployments. So we've got this term called the public cloud. We've got the private cloud. We've got a hybrid cloud. What does it actually mean to someone when we talk about the term public cloud? So public cloud is the most common form of cloud deployment today. The cloud service provider makes all the services sort of available, resources available to end users or the public via the internet. As an administrator, you do not have to worry about the local hardware cost or keeping up with the local hardware up to date. Now, this provides, again, a high level of scalability and resource sharing. It's a multi-tenant platform, and it is possible for a single organization to use the public cloud at a very low cost. So some of the most common public cloud providers today, vendors, are Amazon Web Services, you've got Microsoft Azure and Google Cloud Platform. And in the recent days, I have actually seen a high adoption. At the moment, it seems that Amazon Web Services seems to be the leader, followed by Azure, and there is a certain level of upgrade as well using Google Cloud Platform recently. So this is the public cloud. Now, let's take a look at the private cloud. The private cloud is one cloud environment where it's your own little data center. You've got the infrastructure there, again, which is provided by the cloud vendor, but it is something which belongs to sort of solely one organization. So while the public cloud was multi-tenant, you've got multiple organizations sharing the same infrastructure. In the private cloud, the infrastructure is only shared by yourself, and then there'll be another infrastructure which is shared by someone else and someone else and someone else, but it's not the same infrastructure which is shared by multiple people. So that is the biggest differentiator of the private cloud. So the private cloud is, again, it's like a own data center with a self-service access to compute resources for your own organization. So that's about the private cloud and the public cloud. And then in between, you've got the hybrid cloud. Hybrid cloud is a combination of private cloud and public cloud. It tries to leverage the benefits of both the public cloud and the private cloud platform. The hybrid cloud is essentially sort of useful when some data cannot be sort of used in the public cloud solely, and we have to use a certain level of private cloud in the background. So for example, it's useful for, I don't know, banks, for example, to have, cloud public facing applications in a public cloud, but then the backend, which actually processes customer sensitive financial data, that has to go via public cloud and shouldn't be at all passed on to the public cloud, so to speak. So now that, I hope it's clear with the understanding of the private cloud, public cloud, and hybrid cloud. There's a couple of private cloud vendors out there, and some of them are OpenStack, VMware, Rackspace, and so forth. The differences, again, between private cloud and public cloud is, just to reiterate this clearly, a single client on the private cloud. So the resources are not shared as it is in the public cloud, which has multiple clients. The private cloud could be on-premise or off-prem, but the public cloud has to be off-prem completely. The private cloud is a very high capital cost to set up and maintain, while the public cloud is low cost. You usually have a very high level of IT overhead in the private cloud, and public cloud is low IT overhead, balancing out because you don't have so much compute resources to look after. Private cloud would be fully customizable. So you throw in as much infrastructure, different specifics, but public cloud, you share with what there is already and you work on what there is on that platform. The private cloud is fully private network, so it's not accessible over the internet. So you have to have a private VPN or a VPC or ExpressRoute, etc., to go into private cloud as such. And then you've got the public cloud, which is a shared network, and it is publicly available. And again, private cloud potential sort of customer underutilization as such, and the public cloud is very, very scalable with demand. It will scale as demand grows. Having looked at the different cloud deployment models, which was private cloud, public cloud, and hybrid cloud, let's now look at the other component of cloud services, which is the cloud service model. Now, many of you would have come across these different terminologies here, such as IaaS, PaaS, SaaS. I'm sure you would have come across this, but what are they actually? What do they mean? Where's your responsibilities lying with them? What's serverless? A lot of people are talking serverless these days. So let's take a look. So this diagram here on my screen shows, it's an interpretation. I've taken this up from Azure, and it explains very clearly where your responsibility lies in each of this cloud services model. So cloud services model, there is the IaaS, PaaS, SaaS. IaaS is infrastructure as a service, platform as a service, and software as a service. Now, if you compare this to on-prem, an on-prem data center, you will have the stack of all of these different services. So start from networking, storage, servers, virtualization, operating system, middleware, runtime, data application. They are all solely and fully the business responsibility. And this changes on the infrastructure as a service. The virtualization, server, storage, so the compute side of things, are managed by the cloud vendor provider. The application the data, the runtime, the middleware, the operating system of the services running in the cloud security in the infrastructure as a service is managed by yourself. Hence, the security of all these different components is the business, right? And that moves, and we move on to the platform as a service. So platform as a service, you'd actually see that it becomes a lot more easier because your cloud, your responsibility here is application and data only. And the cloud service provider, the vendor, would be looking after all these other different components, such as the virtualization, the servers, the storage, the networking. The application security side and the data side is yours. Now, in the past, there used to be a sort of a potential neglect sometimes when looking into the responsibilities required for securing your applications and data in the cloud. And thankfully, that is less of a case now. And then there are, more people who are much more aware of what's the business responsibility in these different cloud services model. And then you also have the software as a service. Software as a service, as you can see, the cloud service provider here mostly takes care of all the different components and the entities. Okay, so the cloud service provider, in this case Microsoft, will take care of the application, data, runtime, middleware, storage, networking, virtualization, all of this together. What that means is that this is going to be potentially a subscription as a service, and there will be a sort of assigned users with different kinds of access. So a SaaS application usually comes with two modules. You have an administrator module and you have a user module. The user module is usually used to access software feature which people subscribe to, and the security stays your responsibility, the business responsibility, only at a user level. So what you need to ensure when running a software as a service application is that your users are secured, i.e. the credentials they're using is safe, and their passwords are strong enough, and you're using multi-factor authentication to prevent accounts being brute forced into. So a good example of Office 365, a SaaS is actually Office 365. And then there is the recent trend of what we've seen, sort of information-wise. We've seen serverless computing, which is one of the trending names we've seen at the moment. Serverless computing is, as the name sort of suggests, is not, despite the name, an elimination of servers from the distributed applications, okay? Serverless applications actually just means that the cloud service provider allows you to simply deploy your application in the cloud and scale without any requirements to look into the underlying infrastructure. Okay, so for example, developers bring their own containers to fully manage Kubernetes orchestrated clusters that can just scale up as the demand increases with sudden change of traffic or any spikes or workloads increase. And this is what effectively serverless means. So a set of code being able to be used on a particular runtime sort of serverless container, and that is spun into, and then that becomes serverless computing. And this leads us to the next slide here, which shows you how the different services have evolved. So from infrastructure as a service to platform as a service to software as a service, with function as a service, storage as a service, and database as a service. And this list, I think this is going to really, really increase. And as much as this picture looks very pretty and very colorful, we as security administrators with the right security mindset, we have to be really, really careful about what this actually means underlying to you. As a security administrator, when you look at this, it's overwhelming, and it kind of leads us to this question to ask, is the cloud services then easier to hack? But the answer would be in this slide. And hopefully to understand this and answer this and being able to sort of interpret that and get general development team, operation team to really understand why, as a security person, you need that information, you need to be involved, you need to understand from the beginning of a project that you need to start applying the correct level of security. You need to start thinking of security right at the conception of a project, at the conception of an application development as such. So to actually get there and being able to correctly sort of, articulate this, you need to understand potentially what are the kind of attacks which are prevailing in the cloud lately, sort of trending, and then translate that into what does those actually mean to you? What are your risks with these type of attacks? Why is it the cloud is easier to hack? So let's get into understanding a little bit about the cloud attacks first. So very recently, as recent as last month in May, Checkpoint did a research and we found that there was a new phishing campaign which was discovered. And what was going on in that campaign is there was a lot of phishing attacks happening, and they were impersonating WHO people working at WHO and other popular conferencing platforms. And what they were doing is to try and steal sensitive information. I well believe that at the moment there is a massive fight and competition over trying to find a vaccination for coronavirus, for example, right? So everyone would be, Russia, China, everyone will literally be going forward to find that formula to find the right vaccination, okay? So some of them, I'm not saying this is the case, but potentially could be in the background, that some of them could be part of a organized type of phishing, spear phishing attack, trying to steal those information. So what Checkpoint discovered was there were 192,000 coronavirus related cyber attacks per week in the last 3 weeks, and that is in May. And then there was about 30% increase of these particular phishing campaign attacks over the previous weeks, and almost about 20,000 new virus-related domains were registered, and 17% of them were found to be malicious or suspicious. Now, when you look at this, this is a high amount of, this is just the last 3 weeks of the type of phishing attacks and phishing campaigns which is going on at the moment. So it is very sort of going on and trending, and it kind of opens up the reason why there might be a lot of cloud attacks happening. So this is just one of those phishing attack example, but phishing attack is very, very popular for cloud users, and I'll explain why in a second. And then you've got the web API attacks. Web API attacks are, again, another common source of attacks. So it's something to really watch out for. A lot, because at the moment you'd notice that there's a lot of different tasks running in the background, not really visible to end users over web application APIs, which are very easy to compromise. For example, you've got injection attacks, broken authentication, sensitive data exposure, potential broken access control, and parameter tampering. And these are the type of web API attacks which are just growing, and this is definitely something to watch out for. The next one is the supply chain attack, which is also called a watering hole attack. So with the previous slide, we saw how there's many different deployment services. You've got many different components, each talking to each other, someone doing function as a service, someone doing storage as a service, someone doing, providing different services. So when you look at a big picture of how the business operates, to minimize cost, the business is contracting the services of someone providing function as a service, database as a service, and then doing the web application on the front end. So what they're doing is each of those components are talking to each other in the background. Okay, now these services could be your supply chain, right? So what did supply chain attack mean? It actually is when the watering hole attack is particularly when a hacker is lurking around trying to compromise a specific person, which tries to connect onto a set of known platforms. So for example, if there is an employee who connects to the corporate network, the attacker would be would try to compromise the particular employee, compromise the credentials to try and access the corporate network. So the term watering hole, it actually comes from, it was inspired by good old days, by predators in the natural world who lurk near watering holes, looking for opportunities to attack desired prey. And in the watering hole attack, the predator lurks near sort of niche websites popular with the target prey, looking for opportunities to infect those websites with malware or malvertisements that make the target vulnerable. And this is what makes your watering hole. And we have one slide which looks at assessing your supply chain, understanding and try to see whether if they will adhere by they are not compliant, they adhere by certain rules, they are compliant, etc. So this is part of the overall strategy of understanding cloud security, but also understanding who connects, what are the different components which come and connect into your network, sort of cloud as well. Men in the cloud is, if you are familiar with the security industry, men in the cloud is very similar to the men in the middle, where there is a man, sort of someone who comes in between, starts copying your data and your traffic across because they have tampered your connection and are now getting a copy of all your traffic, and they're potentially diverting your traffic into something else instead of you. And that is men in the cloud. So usually they are eavesdropping, they're there looking at your traffic, they're sniffing your traffic. These are men in the cloud, and it is possible in the cloud, believe me. There is a compromise for, I don't know, keys, specific security keys. If it goes in the wrong hands, this can very much potentially put a man in the middle in the cloud. And then again, we've seen there's a certain time, and this is very seasonal, you'd find a cloud malware injection campaign where suddenly you'll find a target set of, for example, retail, where the websites start getting compromised and they start leaking information, user details also. And then again, there is the usual advanced persistent threats, which is having different type of threats into the network, so bots, etc. As persistent threats. And again, you've got the denial of service attacks. So denial of service attacks somewhat differs for the cloud, and that is because the intention of the DOS attacks for on-prem was very often to stop availability of your web traffic, for example, to legitimate users. Okay, so you DOS someone, so there is no availability, and unavailability is effectively loss of service, causes reputational damage, etc. But in the cloud, because of scalability, the denial of service attack is still absolutely possible. It will still stop legitimate traffic getting through, maybe, depending on how scalable your services are. But when services start to scale, it actually not a denial service attack for that business to lose data because unavailability of application also to end users, but more so to increase the cost. If you think of it that way, the more the DOS you do, if the application scales, okay, and your load balancer scales and is allowed to accept more and more and more illegitimate traffic compared to stopping the illegitimate traffic, it just then increases your cost, and that becomes a big cost to the business, and hence not good again. No one will know about it potentially in the future. However, the attack is still there and the cost increases. Now, how does that translate to cloud services? How do we see, what is the analysis done behind cloud services which make the cloud easier to hack? Okay, one of the main important piece is the accessibility to the cloud platform. So if you think of the nature of the cloud, you'd notice that the cloud platform can be accessed from anywhere via the web browser. You've got different users. You've got your development person, you've got your IT person, you've got your IT security person, you've got your project manager. They are all connecting onto the same cloud platform using different credentials, hopefully, and having multi-users access to do different things in the cloud. And what that also then means is, in reality, in the real world, if you're a security administrator, you very often do not have visibility of the identity of those users who are allowed access to certain applications, services, platforms, administration, consoles into the cloud. Okay, now not just simply you lack visibility of who is connecting, but there's also a severe lack of visibility of what are they allowed to connect to. Okay, not everyone can be a super administrator, not everyone can be an administrator, not everyone can be a reader. So each of those different types of profiles which would be potentially connecting, you as a security administrator in the real world, it's not necessarily that you will have a true visibility of that. So this is an important bit to think in your mind when you're approaching a cloud security assessment, for example. Then the other accessibility issue concern also is that some of the cloud platform applications require applications to require root access. Okay, now this is a no-no. I have to say that if there is an application like this, then I'm sorry, the development guy is doing the wrong thing. Applications or deployment in the cloud should not really access root account credentials. So it must be looked into, and this is something you need to address further down the line when you're doing your cloud assessment. And that's part of the accessibility problems in details. The other bit is, and again, this is extremely common, and I have a very, very good example to give you of misconfiguration. Misconfiguration is one of the most common mistakes to happen in the cloud. Okay, if you guys want to know more about this, I would strongly recommend you Google Capital One attack, which happened last year, and how that happened. So the Capital One attack was due to a misconfiguration on AWS. Believe me or not, it was as easy as just ticking a checkbox to deploy your whole database on the public internet, accessible for anyone to download. And this is exactly what happened with Capital One. And that misconfiguration is, so to put in perspective, when a particular developer is, or a database administrator is putting something in the cloud, they will go through a certain script, and it will be tick, tick, next, next, tick, tick, next, next. Okay. This tick, tick, next, next, if they do not pay attention, could potentially just simply publish information onto the cloud. It is that easy to make such a mistake. Now, you as a security administrator, how on earth would you find out that this mistake has occurred when there is very less visibility in the cloud? A different person is working on a different platform in a different cloud environment at a different time of the day, and the application has the potential to be misconfigured, deployed on the web, and unless someone discovers it by chance, there is a very, very little means of you actually knowing that this has actually happened. So this is something to keep in mind on how do you overcome these specific challenges. And then we mentioned about the unencrypted storage databases. This is again related to the misconfiguration issue. Again, it is very, very, very common for database administrators to simply deploy databases sometimes without encrypting the storage. Hopefully there's less and less of this now. However, there used to be this time when database administrators would not think of security first and foremost. So again, it is our job to have people understand that this is a no-no in best practice, and that security should be considered at any point a particular service is being deployed in the cloud. However, you as a security administrator, you need to be in a position to discover these misconfiguration much quicker, and that then leads us to potentially sort of lack of visibility of asset management. Again, in the real world, administrator, platform administrator, development guy, I don't know, some other development person, front end, back end, they're all pushing updates, they're all deploying all the time, probably every 2-3 days, sometimes pushing updates every few hours. So these kind of agile development, agile deployment of assets, it's very, very difficult to keep track of. So you need a tool which will provide you the instant visibility. As soon as someone spins an instant, you have to know about it. A security administrator alert has to be created, so you know that particular asset which has been deployed, that particular instance which has been deployed has the correct security tagging, and it is being protected by correct policies, and it's been secured. So that's another big challenge for the cloud. The APIs, as we spoke, as everyone is using APIs for each component to talk to each other, it introduces insecure interfaces into different components. And again, there is the checks to be done. As security administrator, again, it depends on where your role is, whether this falls under you or not, which we'll look into shortly. But the security interface and the APIs are very important. And then you've got the security compliance side of things, where you want to have all your assets being compliant at that particular instant they are spun onto the cloud. And this answers the question of why cloud services or your assets deployed in the cloud are so much more easier to hack. Okay, so what does this translate to? What are you exposed to? You're exposed to lateral threat movements. You're exposed to data breaches. You're exposed to abuse of cloud services. You're exposed to API hacking, or even exposed to hosting malicious insiders. So these are your risks. You weigh your risks. Are these applications being deployed in introducing any of these risks in here? So these are the things you need to sort of think and build your security mindset as a security administrator, when you are moving on to the next stages of your security assessment. And part of this Cloud Security 101 is to understand where you stand in the business as are you a cloud security architect, are you a cloud security engineer solely, are you a software engineer, are you DevOps, are you cloud security administrator? And I have to say, as in the cloud, as a security person, you will need to work with all of these different people, or yourself have all of these different roles when administering your security in the cloud and protecting your assets. This is something I have lifted from National Cybersecurity Council and NCS this is from Cloud Security Alliance, and this gives you a good breakdown of the cloud reference architectures. So what's possible in the cloud? How is your business operation support services going? Your information IT ops side of things, your application services, your security, risk, and management side of things. This breakdown is actually very interesting, and I actually recommend all of you to go take a look, see what these different components talk about: application security, information services, where do you sit from there? So from a compliance perspective, where do you sit? What authentication is required? This building blocks actually gives you an idea of what are the different aspects of security I need to look at when something is being deployed, the project is being launched, and so forth in the cloud. So this leads us to one of the new roles people are talking about a lot is DevOps. DevOps is a person who is also a developer, but who is also part of the operational team. And it provides you with a certain amount of freedom and agility, and it provides you you need to have that control and provide and make your security efficient. So one of the problems of cloud is if your security mindset is to actually, I know about on-prem security and I'm going to deploy the same on-prem type security in the cloud. Hold on, it doesn't work exactly like that. The cloud is very dynamic and security in on-prem is pretty static, so to speak. The creation of firewall tickets, for example, are a bottleneck, and and security is very hard to deploy in the cloud. Having said that, there are some measures you can take to try and secure your assets to be as agile, so your security would be as agile as your assets are in the cloud, and it could also be as effective. Okay, and this is another element of cloud security, which is very, very nicely explained on the NCSC side, the National Cybersecurity Council. It actually gives you a guidance and understanding of, say you start your journey on cloud security, you're doing your assessment, you need to look into what are you protecting. You're protecting your data, you're protecting assets, you're protecting users connecting. What are the operational security, people security? How are you making sure that development in the cloud is happening securely? How to check your supply chain and whether if they are as secure to connect into your network as a component. Are you securing your user management? How are you doing your identity and authentication for the users? Do you have to do an audit? How do you secure use of these services? This is a very, very interesting guideline on the National Cybersecurity Council website for you to start your cloud security assessment. The other, we spoke about the supply chain, and then so you, alongside the supply chain, you will also need to run a check on your cloud service provider. So before selecting a cloud service provider, you need to understand what your business requirements are, understand the information which is available for everyone, the data flow, and if you have any specific regulatory implication of any data leak and specific, risks which the business is willing to take. Look at your service supplier assurance claims. Are they really valid? Are they something you can work with? you look at acceptable risks for the business, and so forth. Now, very, very important when you are working with your cloud security is, as a security administrator, you need to have good visibility of your assets, okay? In the real world, and this I'm saying from my personal experience and how I see things rolling across different projects. In the real world, as a security person, you are very often brought in when, say, there's an acquisition, there's a new project being onboarded. There are some great minds, I have to say, doing some great things, and there's great job happening, but there's also a lot of chaos at the same time. It depends, as a security person, at what stage are you brought in to try and secure the asset, to try and secure the data, to protect from any sort of hack going on. So it's really, really good if you're brought in at the beginning of the project, but sometimes we are brought in halfway into the project, and sometimes we are brought in at the end of the project, literally a few days before this particular application project is going to go live. And that doesn't necessarily help you, because it kind of brings a challenge to understanding what are the assets, who are the users, do I have visibility, can you understand the flow of traffic, can you understand who connects, where are the enforcing points. So these are the main points someone needs to understand. And I will stop here for a second. We've got a question. I think someone's asking, can you share the link to the security architecture details, please? Okay, sure, I will certainly do that at the end of this session. Thank you, Alona. Right, so to go back onto the security data assets, securing your data assets in the cloud, we talk about the visibility, how important it is, understanding the flow of traffic, at what point are you brought in, but regardless at which point you're brought in real life, you still have to deliver on these, okay? So where do you start from? You'd start by finding the visibility, to look at a true visibility of all your assets, understand the flow of traffic, look at who connects, and so forth. In addition, of the other challenges we're having today is businesses are connecting to multi-cloud platforms, okay? So what you also need on top of the visibility of your assets, etc., is continuous compliance and governance across multiple platforms, multi-cloud platforms. You need to be able to start evaluating your security and best practices as soon as those assets are being deployed. You actually look into continuous integration of compliance and deployment of your project pipelines. You want a single pane of glass to be able to provide the visibility of all those different assets, and also the compliance across these assets. So we spoke in the previous slide about visibility, we spoke about continuous assessment, we spoke about being able to identify the users connecting onto those different platforms,